Every good movie deserves a sequel. Here it is, folks. Tell your friends, tell your neighbors. Resistors in Parallel. Starring the Ampere family. You know them, you love them, you can't live without them. We're now going to join the further adventures of the Ampere family in their quest to master the parallel circuit. The parallel circuit they're going to go. And they have a choice. Choices make the world go round. And they now have a choice. Again, let's go with 2 ohms, 4 ohms, and 8 ohms. Let's also give them 24 volts to spend. So that way they have 24 volts of current. But now they have choices. So let's take a look at those choices. Now they have a choice for their quests. And their family's a little bit different now. So let's do some calculations. Now the entire family is going to leave from this point. So that's going to be the total Ampere family right there. But when the total Ampere family gets there, they have a choice. They can go there, or they can go there, or they can go there. We'll call this I2. We'll call this I4, and we'll call this I8. And we know that I total must equal I2 plus I4 plus I8. And we know that they're going to split up now. The family are going to take their individual quests to town. But here's the wonderful thing about the quest that they're going to go through now. They start with 24 volts of ancient currency. This is 0 volts down here. Well, let's write that in 0 volts. And we have 24 volts here and 24 volts here and 0 volts here. So around this loop, 24 volts. Around this loop, 24 volts. Around this loop, 24 volts. Amazing. Every time they leave the family and leave the family home and complete a loop, they must use all their voltage. So all of these see the same voltage. 24 volts for that. 24 volts for that. And 24 volts for that. The voltage drops are the same across each branch because they can get back to their home tired and out of voltage. Remember, the entire family was together up here. And I want to figure out how many members of the Ampere family I have today. And here's the nice thing about it. If we have 2 things, we can determine everything. So let's take a look at the 2 ohm resistor first. Once again, we're going to go into our bag of tricks and grab Ohm's law. Dun, da, da, dun! And I is equal to V divided by R. Well, V is 24 divided by 2 is 12 amps. 12 members of the Ampere family go hurtling through that resistor. It's the lowest resistance, so more go that way. The Ampere family is lazy. More will go the easier way. Now, if we go to this resistor here, now, well, Ohm's law once again, dun, 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 dun. 24 volts divided by 4 ohms is 6 members of the Ampere family going through there. Wonderful. That's wonderful. That's so neat. So now we look at the 8 ohm resistor. The 8 ohm resistor, which has the highest resistance. So therefore, the smallest number of the lazy Ampere family are going to go through there. But luckily, we have the advantage of Ohm's law. Dun, 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 dun! And we know that 24 divided by 8 is 3 amps. 3 members of the Ampere family get through there. 12, 6, and 3 add up to 21 members of the Ampere family. They're taking over. They're worldwide. It's 21 amps there. It's 21 amps there. And then they split up when they go through the challenges. 12 took the easy way out and went through the 2 ohm resistor. 6 went through the 4 ohm resistor. And 3 went through the 8 ohm resistor. Next. And as always, we know that I is equal to V divided by R. So therefore, R is equal to V divided by I. So therefore, when I go to solve it, I can simply say R is equal to V divided by I. 24 volts divided by 21 amps. 1.14 ohms. That's the total R. Of course, as always, there are other ways to solve quests and challenges. We can say 1 over RT is equal to 1 over R1 plus 1 over R2 plus 1 over R3 as many times as we need to. In this case, we have 1 over 2 plus 1 over 4 plus 1 over 8. And all of that is equal to 1 over RT. Least common denominators. Well, if we go 8, that becomes 4 over 8. That becomes 2 over 8. And we get 7 over 8. And then we know that RT is equal to 8 divided by 7. 1.14. Oh my gosh! So as the Ampere family works their way around the parallel circuit challenge, a few important things to remember. The resistance total is found by adding the reciprocals of all the individual resistances, as the voltage drops are the same for each branch and the currents add up. A few other rules. When you add R's, R goes down, so I goes up. That's very, very important. As you add more resistors, you're going to need more members of the Ampere family to help you out and work your way through the quest. Also, RT is always going to be less than the smallest individual R. That's due to the overall laziness of the Ampere family, and that's something we need to do something about. And of course, you can always solve a quest by using a verb table. V, I, R, P, R1, R2, R3, total. You know 2 things on a line, you can figure out the other things. We know that the total voltage is 24. Matter of fact, we know it's 24 for each because it's a parallel circuit. We also know that this was 2, this was 4, this was 8. If we get that, 24 divided by 2, 12. 24 divided by 4, 6. 24 divided by 3, 24 divided by 8 is 3. That all adds up to 21. 24 divided by 21 is 1.1487. The math gods are happy. If we take a look at the power, we get 48 watts. We get 6 times 24. Oh my God, that's 144 watts. And then we get 3 times 24, which is 72 watts. 24 times 12 is not 148. I made a math mistake. I hate it when I make math mistakes. 24 times 12 would be 240, and 48 would be 288. That's your winner. That's the one that's going to use the most power. If that's a light bulb, that will be the brightest light bulb, because it gets the greatest combination of I and V. And of course, you can figure out your total power. I will leave that up to you. And of course, if there's a part 1 of a movie and part 2 of a movie, there will be a part 3 of a movie where the Ampere family challenges a combination circuit, coming soon to a theater near you.